Welcome back to my channel, Physics Form 5 KSSM. We continue Chapter 2 Pressure on topic 2.4 Pascal Principle, Part 1. In this video, I will discuss two learning standards. The first one, describe principle of pressure transmission in an enclosed fluid. The second one, communicate about hydraulic system as a force multiplier. The principle of transmission of pressure in a closed fluid. When we talk about closed fluid, meaning the container with the same or constant amount of liquid. The fluid refers to liquid or gas. Anything that can flow, we call it fluid. I hope you still remember what we have discussed in the topic of liquid pressure. Look at this video. From the opening here, we know that there is atmospheric pressure act on the surface of water. Why the water is spurting out from the holes here? So this video shows that pressure that act on the surface of water and also pressure due to liquid will be transmitted to the holes here. The pressure that transmitted causes the water to spurt out at same speed, meaning pressure is transmitted equally to the holes here. We have another one example. This is a closed container actually. We have a piston. What is your observation on the flow of water out of the hose when Pascal piston is pushed inwards? If this one is pushed inwards, force act per unit area will produce pressure. How to explain this situation? First, the piston is pushed. It will exert force on the surface of water. We have discussed earlier, pressure equals to force divided area or force per unit area. Meaning pressure is produced. As you can see, when the piston is pushed down, the water will spurt out through the holes here at same speed. And this situation shows that pressure is transmitted uniformly throughout the water in all directions. So actually, this one is stated by Pascal's principle. According to Pascal principles, the pressure applied on an enclosed fluid is transmitted uniformly in all directions in the fluid. Okay, we will discuss further about this Pascal principle. The system that applied Pascal principle is hydraulic system. Hydraulic system is also known as force multiplier, meaning it will multiply the force applied to produce higher or greater force. That's why we call it force multiplier. According to Pascal principle, pressure applied on the surface of liquid is transmitted uniformly throughout liquid. So you need to memorize. You must be able to state this Pascal principle. If this pressure is transmitted to a larger surface area, what is the effect on the force produced on that surface? To answer this question, I hope you still remember the formula of pressure. Pressure equals to force divided surface area. Or we can write as pressure equals to force per unit area And force is equals to pressure multiplied surface area. If the pressure transmitted is uniformly throughout liquid, or we can say pressure is constant, force is directly proportional to surface area, meaning the larger the surface area, the larger the force produced. Let's watch this video. Okay, this one is a toy car by using leg so the girl can stop the car. How about this car that's traveling at high speed? So we cannot use leg to stop the car. So for this one, driver need to use a brake system to stop the car. So pressing the brake pedal will slow down the vehicle. So you can see it can stop the car. The vehicle brake system using hydraulic system, meaning the force that press on the brake pedal will be transmitted. So this one is based on the hydraulic system that consists of a piston, cylinders, and of course a special liquid inside which is incompressible. So the special properties of the liquid is that it is incompressible, meaning the volume cannot be changed, cannot be compressed. Unlike air, air is easily compressed. So for hydraulic system, it must free of air. So in this one, pressure will be exerted on the liquid, meaning the force applied per unit area. So pressure will be transmitted that causes the liquid to displace from the first piston to the second piston. Because of the liquid is incompressible, so the pressure is transmitted equally and uniformly throughout liquid. So this one is applied for hydraulic system. So for example, the car brake system, you apply small force on the brake pedal. It causes the brake fluid to transfer, okay, the pressure through this one is the master piston. Okay, the fluid will be transferred throughout the tubing in the car brake system to the second piston, we call it slave piston, and produce greater force or output force that able to stop the car. So this one will be discussed more about how it works for the car brake system. So what we want to observe from this video is that applying small force, as an example using the brake pedal, you step on the brake pedal with a smaller force, but it able to stop a car, a high speed of car able to be stopped, meaning the output force that produced is higher, meaning greater force is produced that able to stop the car. So this one also explained that the output force when using hydraulic system is greater as compared to the input force. That's why we call it force multiplier. Okay, so a small force on a small area of piston produces larger force at larger area of piston. So this is hydraulic system. You can refer to your textbook activity 2.7 to study a simple hydraulic system as a force multiplier. Apparatus required is model of simple hydraulic system, 3 pieces of 100 grams slotted weights, 5 pieces of 50 grams slotted weights, 5 pieces of 20 grams slotted weights, and 5 pieces of 10 grams slotted weights. Material or the liquid that used in this model of hydraulic system is water. So this is the diagram. You can look at the label here. It consists of 2 strings. Okay, the first The first shrink here is smaller. Okay, you can see the piston also is smaller. It's connected to the second piston by this tube. You can look at the second shrink is larger, so it has a larger area of piston. Okay, so this model, we call it Pascal model, to explain Pascal principle. Okay, look at this video. This is a simple hydraulic system. Okay, you can look at the shrink here. There are two shrinks, same thing as what I explained this part. So it consists of water. So you can see the level must be the same. This one is the smaller piston. This is a larger piston. Okay. Let's say we put a load of 50 grams on the small piston. So what is the amount of mass that we must put here so that the level become equal again? So we add here mass of 150 grams. So we can see the level here becomes same. So when this happens, meaning 150 grams of load on the larger piston able to balance 50 grams of load on smaller piston. Let's say we put a small piston on the small piston, a small amount of mass, it will cause the larger piston to move. Okay, so meaning smaller input force on a smaller piston will able to lift up larger mass on the second piston, meaning on the second piston the force produced here is greater. So that's explain the principle of force multiplier or hydraulic system. So you can try this in the lab. You can record data. For example, you add slotted weights 10 gram, 20 gram, 50 gram or 100 gram on the large piston until the water levels in both syringes are same again. Then you can record mass of load on both pistons. Okay. So what is hydraulic system actually? So this is hydraulic system. The piston, which is smaller area, this one we call it input piston. The one with larger area, we call it output piston. So the function of hydraulic system is to produce larger output force, meaning applying a smaller input force produce greater output force. Pressure is equals to force divided by area. So it's also equals to larger force divided by larger area for the second piston. Let's look at the properties of the liquid used in the hydraulic system. So here the liquid is incompressible liquid, meaning the volume is constant. It cannot be compressed. The other properties of liquid that used in hydraulic system are high boiling point, because if the piston move up and down repeatedly, it will cause the liquid also to be displaced, okay, from the input piston to the second piston repeatedly, and this one will cause friction also, and maybe will cause heating of the liquid. So it must have high boiling point so that the liquid does not easily change to steam. low rate of evaporation, does not form bubbles in hydraulic systems because we want to transfer the pressure uniformly. So there must be no bubbles in the liquid. Low rusting effect. Pipe does not get rusty easily. Normally it's made of metal, the pipe. So we want to prevent it from rusting. So we use the liquid which has low rusting effect. Low density so that hydraulic fluid can flow smoothly in the pipe. Let's look at the formula that can be produced by using this Pascal principle. According to Pascal principle, pressure applied on the surface of liquid is transmitted uniformly throughout the liquid. F1 over A1 will produce pressure P1. Pressure P1 will be transmitted uniformly throughout liquid to the second piston or the output piston. Let's say the pressure at the second piston is P2. According to Pascal principle, P1 equals to P2. What is P1? P1 is F1 over A1 and F2 divided by A2. So from this relationship, we can rearrange. Thus, we get the output force or the force produced at the second piston equals to A2 divided by A1 multiply F1. The ratio of A2 over A1, meaning area of the second piston over area of the first piston, we call it multiplying factor. Meaning, if area of the A2 is 10 times bigger than area of A1, the multiplying factor is equals to 10. And then we can say that the output force will become 10 times bigger than the input as compared to the input force. So this one is known as Pascal's formula. So that's all about Pascal principle. So the basic concept of Pascal principle. So I will continue in my next video on application of Pascal principle. Okay.